Okay, we're going to look at some more complicated trig equations now. Suppose you were asked to solve 2 sine squared theta plus sine theta equals 1. Now, although it's got trigonometry in it, I hope that this looks reasonably familiar to you. You need to be able to spot that this is actually a quadratic equation. And you should know that to solve quadratic equations, we need to set them equal to 0. And so, first step, there we go. Now this is just the same structure as something like 2x squared plus x minus 1 equals 0. Perhaps it factorises. If it does, then that's going to be the best way to go. If it doesn't, we might have to use the quadratic formula. Let's try it. 2 sine theta times sine theta equals 2 sine squared theta. We want a 1. 1 times 1, that's nice and easy if it works. And we want plus sine theta, but we want these two sines to be different from each other. So I think we'll have a plus 2 sine theta with the outer terms there, and a negative 1 sine theta there, and that works nicely. So we now know that 2 sine theta minus 1 equals 0, and we know that sine of theta plus 1 equals 0. Add 1 to each side and divide through by 2 gives me sine of theta equals a half. Take 1 off each side gives me sine theta equals negative 1. At the beginning of this, I should have provided a range of values to work between, so I think we'll say between 0 and 360. And see what we've got next. So our one question has actually turned into 2 simpler and separate questions. Sine of theta equals a half. Theta equals inverse sine of a half. Theta equals 30 degrees. Over here, theta equals inverse sine of negative 1, and that works out at, I believe, negative 90. Just check, inverse sine of negative 1, yes, negative 90 degrees. As you've seen before, we now need to draw a graph. So actually in this case it's probably more helpful to draw 2 graphs. So we'll have a graph for this one. Let's do it in a better colour. And a graph for this one. Let's produce a decent sketch. We're working with sine. And here, sine of a half. I've got a solution there and a solution there. Over here, I'm interested in negative 1. I've got a solution just there. Okay, so there's my 30 degrees. This is 180. This has to be 150 degrees. Because of the symmetry of the sine curve. Over here, inverse sine, the calculator tells me negative 90. We really need to think about what's happening over beyond the left-hand side of the graph. So, negative 90 is there. What the calculator has found for us is this point. But we want this point, which is exactly 1 wavelength further on. This is out at 270 degrees. If you look back at how I set up the restrictions, I said that we were between 0 and 360. So I don't want the negative 90 solution, I want the 270 solution. So this one here is important, it's part of my working, but it's not part of the final answer. And for that reason, it's best at the end just to summarise what you found. 30 degrees, 150 degrees, 270 degrees. There are 3 solutions to that particular equation.